Good morning, everyone. This presentation provides an overview of how we can utilize geological, geomorphological, and geophysical information to understand the tectonic processes affecting Northern Luzon. On behalf of the research team, I am pleased to introduce to you our research project, Tectonic Consequences of Subduction in Northern Luzon. This research forms part of the program entitled Growth of an Island Arc, which primarily aims to reconstruct the tectonic and magmatic evolution of the Luzon Arc. The objectives of this project will be accomplished through collaborative efforts with colleagues from the Mines and Geosciences Bureau, Philippine Institute of Volcanology and Seismology, National Taiwan Normal University, and National Taiwan University. Now let's review what happens during the process of subduction. Subduction takes place at convergent boundaries where one tectonic plate moves under another plate and sinks due to high gravitational potential energy into the mantle. Furthermore, the subduction process leads to the formation of volcanoes and the generation of earthquakes. A subduction zone manifests on the surface as a trench, a deep bathymetric feature similar to what we see here, the Manila Trench. The Manila Trench accommodates the eastward subduction of the South China lithosphere beneath the Philippine archipelago, or what we refer to as the Philippine Mobile Belt. Along the Manila Trench, the Scarborough Seamount Chain subducts beneath the Philippine Mobile Belt. Recent analysis of GPS, or Global Positioning Satellite data, also tell us that the Northern Luzon Island moves in a northwestward direction at a rate of 60 to 90 millimeters per year with respect to a stationary point here in Pangasinan. These motions of tectonic blocks lead to convergence and subduction along the Manila Trench. So how do all these tectonic forces affect the geology and tectonics of Northern Luzon? Do faults become active? Do we observe uplifted and subsided landforms? Do we anticipate high hazard susceptibility in certain areas? These are just some of the questions that we hope to elucidate as we investigate the region's active deformation or active tectonics. Active tectonics is the study of how tectonic processes are occurring in recent geologic time to present day. It integrates the various fields of geomorphology, structural geology, geophysics, and geochronology. In this study, we first conduct geological mapping to describe geomorphological and structural features. To constrain the movement and geometry of faults, we will also analyze GPS, paleomagnetic, and paleoseismic data. GPS measures how the surface of the Earth moves, and GPS data can be analyzed to estimate surficial velocities along faults. Through paleomagnetic data, we are able to constrain the Earth's past magnetic field and movement of crust. Lastly, in paleoseismic investigations, the geometry, kinematics, and seismic history of faults can be estimated. With all this information, we will now have a better understanding of the region's tectonic setting and deformation characteristics. More importantly, we can provide useful information that will benefit the society in terms of land use planning, engineering geology, and risk assessment, reduction, and management. With that, thank you very much and good day to everyone.